Let's walk through how to draw a Lewis dot structure, and we'll start with a simple molecule as an example. And we'll really only be drawing small molecules in this class. Let's start with water. So I'm going to give you the punchline first and then show you how we did it. So here is a representation of water, and both of these would be Lewis dot structures right here. Over here, we have a representation that's just kind of showing it in 3 dimensions. We're going to build up to this next. So let's focus just on this one. We can represent this in 2 ways. I prefer to use the lines to represent the bonds, so that way they visually jump out as different than the non-bonding electrons that will be lone pairs around the atoms. So in this case, we can see that although with the dots, you can see that there's 8 electrons that are around that oxygen that show it sharing electrons with hydrogen to the point where it actually has 8 around it. And the hydrogen bonding and oxygen bond electrons, these are these ones right here. So these are the ones that are participating in the bonds, the ones that are sandwiched in between the oxygen and the hydrogen. All right, so let's walk through step by step how to represent this. So first, we're going to determine the number of bonds for each of the elements that we're going to be working with. And so we have oxygen and we have hydrogen. I like drawing the electron dot symbols to help me with this, but you can also just kind of write it out or track it in your head. So we can see that our oxygen has 6 outer electrons, and our hydrogen has 1 outer electron. To determine the number of bonds, I'm going to do 8 minus 6 outer electrons for my oxygen atom. That's going to give me 2. So I expect 2 bonds for my oxygen. Hydrogen doesn't follow the octet rule, right? It has the duet rule. So I'm going to think of it as my goal is 2 instead of 8. I'm going to subtract the 1 outer electron it has, which will equal 1 bond. All right. So my hydrogen, I expect to have 1 bond. And my oxygen, I expect to have 2 bonds. All right, now I'm going to start constructing the actual structure. So it says to draw the electron dot symbol in the center that needs the most bonds. So comparing oxygen and hydrogen, oxygen needs 2, hydrogen needs 1. So I'm going to start with oxygen since it needs the most bonds to it. I'm going to write its electron dot symbol. And I'm going to think of this as the center of my molecule. Now I'm going to make covalent bonds between the remaining unpaired electrons, which I'll highlight real quick. So I've got 1 here and 1 here. I do this method that you probably won't see in the textbook. They kind of share a different method, and there's a couple different ways of doing this. I like this connect the dots method because it helps me track my electrons better. As someone who's really prone to making simple mistakes or flipping things around or accidentally dropping my pen and making a dot on my page and then thinking it's an electron later, I like doing this a little bit more because it allows me to double check things on the atom by atom level for these structures rather than double checking the whole structure, which I'll show you here in a bit. So I've got these 2 spots. I'm going to start making covalent bonds. Now, my chemical formula, which I probably should have started with, is H2O. So as I'm doing this, I have 1 oxygen and I have 2 hydrogens to build with. So I am going to have a hydrogen come up here. It has 1 electron. There's its electron dot symbol. Doesn't really matter where I put that 1 electron. I'm just going to make it easy to see. I'm going to bring these next to each other. And so these are going to form covalent bonds. And now at this point, I can represent it one of 2 ways. I can either represent it as electrons sandwiched in between the oxygen and the hydrogen. or I can use lines like that. I'm not going to use the lines for the lone pairs. I'm going to show them as a pair of 2 electrons, not doing anything with anything else. And so both of these are reasonable Lewis dot structures. And at this point, when we do a Lewis dot structure, it doesn't matter if I have this angle in it or if I draw it like this instead, where it's all in a line. These are equivalent. They're the same thing. I could do the same thing over here. One thing that's a nice trick, especially when we start working with more atoms, is I always place my hydrogen or my halogens, which are anything with that, like the fluorine, chlorine, in that, anything in the seventh group. And that's because they all only need one bond. And I like to kind of count up and see how many places I have to place those atoms. And if I have a lot more electrons that need to form bonds than I do atoms to bond them to, I usually am going to have to make multiple bonds. And so if I place the hydrogen last, it helps me see that I need to do that a little bit better. I get kind of a hint. Now, to double check these, I like to go around and make sure that every atom is obeying its octet or duet rule. And so for the oxygen, I could see that it has 8 electrons around it. It has two pairs of bonds. So that equals 4 electrons. And it has 2 lone pairs. Each lone pair has 2 electrons in it. So that's also 4 electrons. So it has 8 electrons. Yay. Looking at the hydrogen, I can see that it has 1 bond, and that equals 2 electrons, and no lone pairs. So that's going to equal 2 electrons, which, because it's hydrogen and it's weird, is exactly what we're looking for. So I could see the other hydrogen is the same. It has just the 2 electrons. So these are following their octet and duet rule. I could count up the total number of electrons that are in my structure and make sure it is the same number as the outer electrons of all of my atoms summed up. But I kind of like this method better.